Hey everyone, Wabi here. Welcome back to our journey through the universe. Today, we're diving into one of the most mysterious, mind-bending, and misunderstood objects in all of space, the black hole, from sci-fi movies to textbooks. Black holes are often portrayed as cosmic monsters that devour everything in their path, but the truth is far stranger and way more fascinating than most people realize. And if you love uncovering secrets of the universe like this, make sure you stick with me until the end. Trust me, you won't see black holes the same way again. What exactly is a black hole? Is it really a hole? Is it a star? A vacuum cleaner of the cosmos? Or is it something far weirder? The truth, a black hole isn't an object in the way we usually think. It's a place where gravity is so extreme that not even light, the fastest thing in the universe, can escape. That's right, when you look at a black hole, you're not seeing the black hole itself. You're seeing the cosmic void it creates. And here's the crazy part, black holes don't just destroy. They shape galaxies, bend time, and may even hold the key to unlocking the ultimate laws of physics. Section 1. Birth of a black hole. Let's start at the beginning. How do black holes form? When a massive star, far heavier than our Sun, runs out of fuel, it collapses under its own gravity. Usually, stars balance to forces: gravity pulling inward and nuclear fusion pushing outward. But once the star runs out of fuel, fusion stops and gravity wins. The core collapses, shrinking down into something unimaginably dense. If the star is big enough, that collapse doesn't stop at a neutron star. It keeps going until it forms a singularity, a point of infinite density, wrapped in an invisible boundary called the event horizon. That's the point of no return. Now, pause here for a second. If you're enjoying this breakdown of how stars live and die, and how they transform into black holes, make sure to subscribe because we dive into mind-blowing space facts like this every single week. Action 2. What happens inside? Here's where things get truly bizarre. Inside a black hole, the laws of physics as we know them break. At the center, we believe there's a singularity, a point where density becomes infinite and space-time itself curves infinitely. It's a place where Einstein's general relativity collides head-on with quantum mechanics. And we just don't have the math to fully explain it. What we do know is that the event horizon marks the border. Cross it, and escape is impossible. Not for spaceships, not for light beams, nothing. From the outside, it looks like whatever falls in just freezes at the edge, time slowing to a crawl. But from the inside, you'd fall right through toward the singularity where reality itself unravels. Imagine trying to explain this to someone who has never heard of gravity. That's how strange this is. Quick question for you. If you had the chance to safely observe a black hole up close, would you do it or stay far away? Drop your answer in the comments below. I'd love to hear how brave my space explorers are. Section 3. Black holes and time. Black holes don't just trap light, they warp time itself. Near the event horizon, time moves slower compared to the outside universe. This is called gravitational time dilation. If you hovered safely near a black hole for an hour and then returned to Earth, you might find that years or even centuries had passed for everyone else. Yes. Black holes are basically natural time machines. Not the kind that lets you control when and where you go, but a one-way ticket into the future. And if you're fascinated by this idea of time travel through physics, hit that like button. It lets me know to make more deep dives into concepts like this. Section 4. Do black holes really suck everything in? Here's a big myth. Black holes are cosmic vacuum cleaners. That's not true. If our sun were suddenly replaced by a black hole of the same mass, Earth wouldn't get sucked in. We'd keep orbiting as usual, just in darkness and cold. Black holes don't magically pull harder than regular stars. Their gravity depends on their mass. Just like anything else. What makes them unique is how close you can get before gravity becomes inescapable. That's why only matter that crosses the event horizon is trapped forever. So, black holes aren't space monsters, they're just gravity taken to the extreme. Section 5. Why black Holes matter, you might wonder. Why should we care about these cosmic oddities? Well, black holes are not just destructive, they're creative forces. At the center of most galaxies, including our Milky Way, sits a supermassive black hole. These giants help shape galaxies, influence star formation, and fuel some of the brightest objects in the universe, quasars. Powered by matter falling into black holes at incredible speeds, and studying them pushes physics to its limits. They're the ultimate laboratories for testing Einstein's theories, and maybe one day, for unlocking the long-sought theory of everything that unites relativity and quantum mechanics. If that excites you as much as it excites me, you're definitely in the right place. Make sure you're subscribed so you don't miss future episodes where we unravel more cosmic mysteries. So, let's recap. Black holes are born from dying stars. They warp space-time, and even reality. They're not vacuum cleaners, but extreme gravity wells, and far from being just cosmic destroyers. They shape galaxies and may hold the keys to the deepest secrets of physics. Next time you see an image of one like the famous photo of the black hole in M87, remember, you're not looking at an object, but at the shadow cast by the ultimate warp in space-time. If you enjoyed this journey into the darkest places in the universe, give this video a thumbs up, it really helps more people find the channel. And don't forget to subscribe if you want to keep exploring the cosmos with me, Wabi. We've got so many more mysteries ahead. Until next time, keep looking up and keep wondering.